Welcome to the tutorial on Lesson 8.3, Number of Solutions for Linear Systems. At the end of this lesson, you will be able to explain why systems of linear equations can have different numbers of solutions, identify how many solutions a system of equations has by looking at the equations, and solving problems involving linear systems with different numbers of solutions. When two lines are graphed on the same grid, they do not always have one point of intersection, or exactly one solution, as we have seen in lessons 8.1 and 8.2. A system of linear equations may have one solution, no solutions, or an infinite number of solutions, and we are going to have a look at what that means. So let's look at a couple of definitions. The first definition we want to look at is what are parallel lines. Well, parallel lines are lines that run side by side but never actually touch. They do not intersect at all. Therefore, a system of parallel lines will have no solutions because the lines will never meet or touch. And if we look back to lesson 8.1, that's what it meant for a linear system to have a solution, was that they had to meet, or it was the point where the lines intersected. If we have a look at this graph of the two parallel lines, we'll see that the red line has the same steepness as the blue line. Therefore, their slopes are going to be equal. So the slope of the blue line is going to equal the slope of the red line. Because they have the same steepness, they will never cross, and therefore there is no point that would satisfy both linear equations or make them both true. The second type that we need to look at is coincident lines. Coincident lines are lines that occupy the same position on a graph. Coincident lines will have an infinite number of solutions because the lines are equivalent. They are actually the same line. If we look over here at the graph, this example, we see we have a red line and a blue line, and they go directly on top of each other, or like the blue one is directly on top of the red one. Because they're the same line, they have the same slope, and all the points on each line are on the other line. Any point on these lines is considered a solution because it would make either equation true. Before we even solve a system of equations, we can actually predict the number of solutions that the linear system might have by comparing the slopes and the y-intercepts of the equations. And just to predict the number of solutions, we can predict if it has one, none, or an infinite number of solutions. First, let's look at intersecting lines. Any two lines that intersect will have one solution because there is only one point of intersection. If you compare the equations of these two lines, they will have different slopes and the same or different y-intercepts. But it is very important that they have different slopes. Two equations might look like y equals 2x plus 5, and a line that might intersect with that might be negative x minus 4. Because those two slopes are different, this one has a slope of 2 and this one has a slope of negative 1, those two lines will intersect at some point. Two lines that have no solutions to the system of linear equations are parallel lines. Two lines that are parallel will have equal slopes. So when you're looking at the equations, comparing their slopes, they should be the same. However, their y-intercepts need to be different because they can't, if they cross the y-axis at the same point and had the same slope, they would actually be the same line, which we'll talk about in a second. Parallel lines that have the same slope might look like this. So we might have y equals 2x plus 1. A line parallel to that needs to be y equals 2x, but the y-intercept can be anything but 1. It could be -2. Because those two lines have the same slope and different y-intercepts, they are parallel and will have no solutions. Again, we're looking at the equations to try to predict how many solutions there are. When you're looking at the equations, you compare the slopes and the y-intercepts to see what type of linear system you have. The third type of linear system is the infinite or the coincident lines system, which has an infinite number of solutions. Coincident lines, because they are the same line, will have the same slopes and the same y-intercepts. So they really have to be identical lines. So you might have y equals 2x plus 1, and the other line will also be 2x plus 1 in its most simplest form. So let's look at example 1, where we can compare a couple of equations that form a system. And we want to predict how many solutions this system would have and check it on our graphing calculators. For the first equation here, we identify the slope. The slope is the number in front of the x. So the slope in this first equation is equal to 2. In the second equation, the slope is equal to 1/2. Because our slopes are different, our system will have one solution. The lines will intersect at some point because the slopes are different. If you are doing this on your graphing calculator and you want to check that they actually intersect, you want to type the equations into the y equals menu. And you have to make sure that they're in y equals mx plus b form in order to type them in. Press graph. If you can't see the intersection or you can't tell that they will intersect eventually, you'll need to adjust your window settings so that you can see these graphs. Please see my tutorial videos on how to adjust window settings on a graphing calculator. Sometimes the equations are not given to you in a nice y equals form. In order to be able to compare the slopes and the y-intercepts of the lines, the equations must be in slope-intercept form, or y equals mx plus b. So if we look at our next example here, example B, we have two equations that are not in y equals form. So I'm going to go ahead and I'm going to put them in y equals form. So for the first one, 4x plus 10y equals 30, I need to get y by itself, so it's in y equals mx plus b form. So I'm going to move the 4x term to the other side by subtracting it from both sides. That leaves me with 10y equals negative 4x plus 30. I want to write my x term first, and because we were subtracting it, it will be negative. Finally, to get y by itself, we need to divide by 10 to get rid of the 10 in front of it. So we divide every term by 10 in the equation. And we are left with y equals, now negative 4x over 10 can simplify to negative 2 over 5x. You could have the x written with the 2 in the fraction or just outside of the fraction. It means the same thing. Plus 30 divided by 10, which equals 3. So there's our first equation in y equals form. And we can see that our slope is negative 2 over 5, and our y-intercept is positive 3. So let's rearrange the other equation to see if we can get the same thing or maybe different y-intercepts. And we'll check it out here. So we need to do the same steps. We're going to subtract the x term from both sides, so that we're left with 5y equals negative 2x plus 35. And then divide both sides by 5 to get y equals negative 2 over 5x. And 35 divided by 5 is 7, so we got plus 7 on the end. All right, so in this equation, we see we have a slope of negative 2/5, and a y-intercept of positive 7. So now we compare the slopes and the y-intercepts from each equation. The slope from the first equation and the slope from the second equation are the same m value. However, the y-intercepts are different values, so they have different b values or y-intercepts. Therefore, we can conclude that this system of equations are parallel lines. Same slope, different y-intercepts means no solutions. If we look at example C here, we also have two equations that we need to isolate y for. So I'm going to go ahead and write down the equations, and we will start by isolating y in the first one. Because my y term is negative, I want to be careful of that subtraction or negative sign there because we can't lose it. 10x is positive, so we're going to subtract 10x from both sides. That leaves us with negative 6y because 10x minus 10x is 0, and 0 minus 6y is negative 6y. Then we'll have equal to negative 10x minus 12. Finally, to get y by itself, I need to divide both sides by negative 6. Got to make sure that negative is in there. Negative 6 divided by negative 6 is just positive 1y left over, and that will be equal to negative 10 divided by negative 6, which is 5 over 3, and it'll be positive because we have a negative divided by a negative, so it equals a positive, and then negative 12 divided by negative 6 is positive 2. So our equation is y equals 5 over 3x plus 2. For the second equation, y is already on the left side of the equation by itself. So we just need to divide every term by 21, and then we'll have y by itself. 42 divided by 21 is just 2, and 35x divided by 21 is going to be 5 over 3x. 35 divided by 21 simplifies to 5 over 3. If we look at our two equations, we will see what the slopes and the y-intercepts are and how they compare. So in this one, the slope is 5 over 3, and in the second equation, the slope is also 5 over 3. Because remember that m value is the value multiplied by x. Also, our y-intercept in the first equation is 2, and the y-intercept is positive 2 in the second equation as well. So because the slopes are the same and the y-intercepts are the same, they are coincident lines and have an infinite number of solutions. And same y-intercept, coincident lines, and an infinite number of solutions. Please check out part 2 of this video for the last example and the key ideas.